All right. In our last video, we were taking a look at, we had two rules for two different parametric equations. Two rules, one for the x-coordinate, one for the y-coordinate. Each rule was based on some input variable called t. So I would just input certain numbers for t into both the x and y coordinate equations, get some kind of output here, and then I would plot those points on a graph here. So here, we're kind of doing something similar, but maybe a little bit backwards. I've got x and y coordinates for 3 points, and I'm just trying to come up with some sort of a rule where I can input a variable t into all of these and get these outputs. Now, this is a kind of an interesting situation where there are many different right answers, right? So there isn't like a single right answer. Of course, there's also lots of wrong answers. So all we're trying to do is come up with a rule where I input t and I output x. And then I input t, the same t, and output y. And I don't have to come up with a special rule that works for both of them. I've just come up with two separate rules. So I'm treating this like two separate tables, tx and ty. And on top of that, I can put the points in any order I want. Well, I mean, I shouldn't say any order I want. I can go forwards or backwards. It doesn't really matter. And for my t values, I can kind of start anywhere, and I could kind of skip up or down by whatever I want. I'm just going to choose 0, 1, and 2. That's all. I could have gone 3, 4, 5, 9, 8, 7, 11, 15, 26. It doesn't really matter. All that matters is that I can write a rule where I input 0, output 7. Input 1, output 5. Input 2, output 3. All right, so that's it. And for this one, okay, my rule for x, if you go back to your Algebra 1 days, writing rules to match tables, the first thing I would look at are what are the differences here. And our differences here are all plus or minus 2. We're going down by 2. And here, our differences are going plus 1 by design. So this is going to be some sort of a variation on negative 2t. Our coefficient is going to be a negative 2. But negative 2t would give us outputs of 0 and negative 2 and negative 4. And I don't want that. That would give us 0, negative 2, negative 4. But I want 7, 5, and 3. And to adjust for that, I just have to add 7. So I'm going to write plus 7. And I don't like this dangling negative out front. I want to clean it up a bit. So I'm going to write that as 7 minus 2t equals x. Now let's do the y. Notice 7, 4, 1. We are going down by 3. Down by 3. And over here we're going up by 1. So the slope, I guess in a sense, this isn't really the slope of this line over here, but kind of the rate of change of y with respect to t would be 3 or negative 3 to 1. So y will start out with some kind of negative 3t. But then to adjust for that, because that rule, negative 3t, would output 0, negative 3, and let's see, negative 6. I don't want 0, negative 3, and negative 6, which is what this rule would output. I need to adjust it by adding 7 to each of these. So it's plus 7. And then I just want to do a little bit of an adjustment here. I don't like the negative hanging out up front, so I'm going to write it as 7. Oops, sorry. I'm going to write it as 7 minus 3t equals y. Okay. So the process here is you plot your points, lay out your xy table, put a column for t, pick values for t, pick something simple. 0, 1, 2, 1, 2, 3, something like that. Don't make it super complicated on yourself. And then you're looking at what's my change in x with respect to t, and that tells you what your coefficient is, and then you have to figure out, you have to add or subtract something to adjust. So you start with your coefficient. So I knew this was negative 2 over 1, so I knew our coefficient of t was negative 2, but then I knew that that would output me, negative 2t would be 0, negative 2, negative 4. I don't want those. I want 7, 5, 3, so I had to adjust by adding 7. Then over here, I wanted, I know that my change in y with respect to t we're going down 3 every time t went up 1, so our coefficient was negative 3 over 1, or just negative 3. But if I use the rule y equals negative 3t, I would output 0, negative 3, and negative 6. I don't want those three numbers. I want 7, 4, 1. So I had to adjust again by, again, adding 7. So my rule ended up being 7 minus 3t. All right. I just decided I'm going to do another example of the same problem. So I have the same 3 points, 3, 1, 5, 4, 7, 7. I'm going to use the same t values, but I'm just going to reverse the order of the points to show you that we could come up with a second pair of rules that works. It is right, but is different. So here, notice how we're going up by 2's this time. And here we're going up by 1's plus 2. So my coefficient of t is going to be 2 over 1, or 2. So that's 2t. But that would output me 0 if I use this rule as is. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. I'm off by 3 each time, so I have to adjust by adding 3. For y, we're going up by 2's. Or up by, wait a minute, this is a 4. I wrote it down wrong. That's, oops. Okay. So we're going up by 3's. Up by 3's. And the t goes up by 1, so our coefficient will be 3 over 1, or 3t. And of course, if I use that rule as is, 3 times 0 is 0. 3 times 1 is 3, and 2 times 3 is 6. So in this case, I would get 0, 3, 6 if I use the rule as is, but I don't want that. I want 1, 4, 7, so I have to adjust by adding 1. So these rules here, 3t plus 3 and 3t plus 1, will also work. I just use some, kind of change my t values a little bit. I could change them again. I could use t values of, say, 1, 2, and 3. So here, I'm going, let's see, down by 2, down by 2, up by 1, up by 1. So my coefficient of t will be negative 2 over 1. So negative 2t. But that would output me negative 2, negative 4, and negative 6. So I'd be off by 9 each time. So I have to adjust by doing plus 9. Over here, I'm going, it's 7 to 3 is minus, I did it again. It's supposed to be a 4. But, yeah. So we're going down 3. And here we're going down 3. So our coefficient of t will be negative 3 over 1, or negative 3t. But if I use that rule as is, negative 3 times 1 is negative 3, negative 2 times 3 is negative 6, negative 3 times 3 is negative 9. So it looks like I want to be 10 off each time, so I have to adjust by adding 10 to the rule. So all of these rules work. Notice they all have something in common. They all have either a positive or a negative 2 for our coefficient of t, and they all have either a positive or negative 3 for the coefficient of t on the y rule. And whether or not it's positive or negative kind of depends on what order we lined the points up in. So again, overall process, set yourself up with a table, an XY table, put your points, pick values for t. I would recommend picking 0 every time, because that's an easy one to work with. 0, 1, 2, 3, whatever. Then you're looking at what are your changes in x and what are your changes in t. And if you pick well with t, make them one space apart every time, 0, 1, 2, 3, 4, whatever. And then your coefficient of t with the rule will just be whatever your differences are here. Keep in mind positive or negative. And then you just have to figure out what would my output be if I use the rule as is, and then it'll have to be adjusted by adding or subtracting. And do the same thing for y. Make sure when you're done, you test. For example, 7 minus 2t equals x. Well, 7 minus 2 times 0 is 7, so the rule works. 7 minus 2 times 1 is 7 minus 2, it's 5, so the rule works. So you want to test to make sure that the rule you made actually works. All right, now we're ready to move on.